equal to tan inverse of x root 3 divided by 2k minus x, and capital B equal to tan inverse of 2x minus k divided by k root 3. Then A minus B is what? 4 options are given. Actually, about x and k, no separate conditions are given. That's why I am taking x equal to 1, k equal to 1. This is the shortcut. Therefore, capital A is equal to tan inverse of x means we put 1 into root 3 divided by 2 minus 1. So capital A equal to 60 degrees. Next, capital B is equal to tan inverse of 2 x1 k1, 2 minus 1 divided by root 3, that is equal to 30 degrees. So therefore A minus B, 60 minus 30, that is equal to 30. The second option is right. Hence the problem. Find the number of solutions of the equation. It is given as tan inverse of x minus 1 plus tan inverse x plus tan inverse of x plus 1 equal to tan inverse of 3x. So the given equation is for our convenient, it can be written as tan inverse of x minus 1 plus, just you write tan inverse of x plus 1, that is equal to tan inverse of 3x minus tan inverse x. So for our convenient, for easy calculation, we take the given equation like that. Okay, now it is in the form of tan inverse of x plus tan inverse of y. Here also tan inverse of x minus tan inverse of y. Actually, you come here. Here the standard formula tan inverse of x plus tan inverse of y equal to tan inverse of x plus y divided by 1 minus xy. Similarly, tan inverse of x minus tan inverse of y equal to tan inverse of x minus y divided by 1 plus xy. So, using that, LHS is tan inverse of x minus 1 plus x plus 1 divided by 1 minus x minus 1 into x plus 1, that is equal to tan inverse of, it is 3x minus x divided by 1 plus 3x into x. So that implies tan inverse of minus 1 plus 1 cancel, it remains 2x divided by, here 1 minus, it is in the form of a minus b into a plus b. So it is x square minus 1 square. So it is 1 minus x square minus into minus plus 1. So 1 plus 1, 2 minus x square. It is 2 minus x square, that is equal to tan inverse of 3x minus x, 2x by 1 plus 3x square. So easily we can write it as 2x divided by 2 minus x square equal to, this is 2x divided by 1 plus 3x square. So we can cancel the numerical values like that. After that, take the right step. It can be x into 1 plus 3x square equal to x into 2 minus x square by cross multiplication. So that implies here x common. It is 1 plus 3x square minus of means minus 2 plus x square, that equal to 0. So that implies either x equal to 0 or simplification 3x square plus x square it is 4x square, 1 minus 2 minus 1, that is equal to 0. Then x square equal to 1 by 4, that implies x equal to plus or minus 1 by 2. Therefore, according to mathematical steps, we are having three solutions: x equal to 0, another is 1 by 2, another is minus 1 by 2. But sometimes all the values of x here, they may not be satisfied by the given equation. That's why we should not believe the number of values of x after taking mathematical steps. In the examination hall, once again, we have to verify all the given values. Sometimes some values should not be satisfied by the given equation. But here, x equal to 0 will be satisfied, and x equal to 1 by 2 will be satisfied, and x equal to minus 1 by 2 also satisfied to the given equation. You can verify this at your home. Therefore, the number of solutions are 3. That's all. If A1, A2, A3 and so on An are in arithmetic progression with a common difference small d, then what is the value of tan of something like that? Here, first the question is equal to, actually it is tan inverse of d. D means what? Common difference. Means for our convenient, I am taking the common difference like that, A2 minus A1 in this term, because it contains A1, A2. That's why we can write the common difference A2 minus A1 and A3 minus A2, A4 minus A3, just like that. We can take any difference because it is common difference, D. Okay. Next, here A1 into A2 terms are there. That's why with respect to these two terms, we are taking common difference. You must catch it. Otherwise, this question will become very tough. Next, second term, plus tan inverse of. Similarly, A2, A3 is there. That's why we must take the common difference or difference with respect to A2, A3 only. A2, A3 means it is A3 minus A2 divided by 1 plus A3 into A2. Why? Because this term contains A2, A3, but this term contains A1, A2. Therefore, for mathematical convenient, we wrote A2 minus A1. Here A3 minus A2. Next A4 minus A3, just like that. Okay. Plus and so on. Plus tan inverse of. Here the denominator is 1 plus an into an minus 1. So with respect to these two terms, we can write d is equal to an minus 1. It's a preceding term. So this is within tan. Okay, so that is equal to tan of. It is nothing but tan inverse of A2 minus tan inverse of A1. How? You come here. Tan inverse of, one simple formula is there. Capital X minus capital Y by 1 plus xy equals to tan inverse x minus tan inverse y. Using this here or applying this here, it is simply tan inverse of A3 minus tan inverse of A2 plus and so on, plus the last term is tan inverse of an minus tan inverse of an minus 1. So that is equal to tan of here 2 cancel, 3 it will be cancelled, A1. A1, is it cancelled? No, it should not be cancelled. It should not be cancelled. Okay, later you come here. It's a preceding term. A(n minus 1) will be cancelled here. So therefore, ultimately it remains only two terms. Namely, it is tan inverse of an minus tan inverse of a1, just like that. So on opening this bracket or using this formula, all terms will be cancelled except two terms, namely minus tan inverse of a1 and plus tan inverse of an. So that is equal to, again it is in the form of tan of a minus b. Tan of a minus b. Tan of a minus b is what? Tan a minus tan b by 1 plus tan a tan b. So tan a means here tan of a means tan inverse of an, that is equal to an, because tan inverse of x equal to x, standard formula. So using that, it remains only an minus a1 divided by 1 plus an into a1. First you verify the options. An minus a1 not there, but in the denominator an into a1 means it is in the second option and third option also. Okay, answer may be in second option or third option. It is out of question. Next, here one observation. You come here. In AP arithmetic progression, Tn is equal to a plus n minus 1 into d. Here, nth term can be taken as or written as an, and first term, a stands for the first term, means T1. It can be taken as a1, that is equal to n minus 1 into common difference d. So that implies an minus a1 is equal to, it is plus an minus a1 is equal to n minus 1 into d. So therefore, this an minus a1 can be taken as n minus 1 into d divided by 1 plus an into a1. So which option is right? Second option is right. So therefore, main two key points are there, namely number 1, nth term in arithmetic progression, Tn is equal to a plus n minus 1 into d. Tn means nth term can be taken in terms of s. So an is equal, a means here first term, a1 plus n minus 1 into d. From this equation, we are having an minus a1 is equal to n minus 1 into d. This is the first observation. Second observation, the common difference d can be written as or can be taken as according to the situation, according to the terms. Why? Because whenever a1, a2, a3 and so on, an are in arithmetic progression, then a2 minus a1 is equal to a3 minus a2, that is equal to a4 minus a3, that is equal to, and so on, that is equal to last term an minus its preceding term. It is called the common difference d. So therefore, according to this term, we are defining d. Here d means we are taking like that. Here d means we are taking like that. Perhaps all the meanings are same. That is equal to d. Hence the problem. Important problem. Tan inverse of c1x minus y divided by c1y plus x plus tan inverse of c2 minus c1 divided by 1 plus c2 c1 plus and so on, plus tan inverse of 1 by cn equal to dash. Four options are given. Here we have to take one special step. Here it can be written as tan inverse of c1 x minus y divided by c1y plus x. It will be like that. So for our convenient, actually tan inverse in numerator minus is there. So we are trying to obtain the form tan inverse of something x minus something y. If minus is in numerator, then definitely plus will be in denominator. That's why we are trying to obtain 1 in this place, for which divided by C1y whole divided by C1y. Then next step, in the next step, tan inverse of C1 get cancelled, it remains x minus y cancel, 1 by C1 whole divided by, it is 1 plus, it is just as x by y into 1 by cy. Gradually we are obtaining this form. Later in the next step, simply we are writing tan inverse of x by y minus tan inverse of 1 by C1, just like that. Okay, I will write tan inverse of x by y minus tan inverse of 1 by C1. So this is all about first term. Okay, it is over. Next, plus second term. Similarly, we must try to obtain 1 here. Okay, already 1 is there. Therefore, directly we can write it as tan inverse of C2 minus tan inverse of C1. But here tan inverse of C1 is not there. 1 by C1 is there. Therefore, even if we are having 1 here, we are trying to express this value in terms of reciprocals, 1 by C1, 1 by C2, like that, for which numerator, denominator, for which divided by C1, C2, divided by C1, C2, like that. Okay, in the next step is, it is tan inverse of, on separating the fractions C2 cancel, it is 1 by C1 minus 1 by C2 divided by C2 C1 cancel, it is 1 plus 1 by C1 into 1 by C2. Next step, it will be very clearly tan inverse of 1 by C1 minus tan inverse of 1 by C2. Of course, it will be the last but one step. In the last but one step, we are getting 1 by C1, 1 by C2, 1 by C3, 1 by C4, just like that. To obtain reciprocals of C1, C2, C3, we did like that, even if 1 plus something is there. Therefore, by mistake, don't do like that. Sir, don't ask me like that. Sir, it is already, it is tan inverse of x minus y divided by 1 plus x into y is there. Na? You can write directly tan inverse of, tan inverse of C2 minus tan inverse of C1. No, it is wrong step. Why? Because in the first term or in the first step or first term, it is expanded as in terms of 1 by C1, just like that. That's why in each and every step we are getting the terms 1 by C1, 1 by C2, 1 by C3, 1 by C4, just like that, for which we are doing like that. Okay, let us consider the third term, tan inverse of, similarly, C3 minus C2 divided by C3 C2 whole divided by 1 plus C3 C2 divided by C3 C2. So, plus tan inverse of, it is 1 by C2 minus 1 by C3 divided by C3 C2 by C3 C2 get cancelled, it remains only 1 divided by 1 by C3 C2 means 1 by C2 into 1 by C3. So therefore, plus and so on, plus last term is tan inverse of 1 by Cn. 1 by Cn. Okay, here this will be tan inverse of 1 by C2 minus tan inverse of 1 by C3, 1 by C3 plus and so on, plus tan inverse of 1 by Cn. So observe C1 1 by C1, 1 by C1, 1 by C2, 1 by C2, 1 by C3, 1 by C3. In the same sense, all will be cancelled, and it remains only it is tan inverse of x by y. Hence, the option is tan inverse of x by y. That option is right. Hence the problem. The solution set of the equation tan inverse x minus cot inverse x equal to cos inverse of 2 minus x. Already we know that cos theta always lies between plus 1 and minus 1. Okay, and we don't have the solution for the equation cos theta equal to 2. Okay, because it is beyond the limits greater than 1. That's why 0 is here and 0 is also here in this interval. That's why first take x equal to 0. So put x equal to 0. By putting x equal to 0, it remains cos inverse of 2. But cos inverse of 2 is not defined. Therefore, x equal to 0 should not be happen. Therefore, bluntly we can cancel the first two options because 0 is here, 0 is here. Next, third option, it is only singleton set. It is open interval of 1, 3. Already you did know the complete meaning of open interval and closed interval and half intervals. Okay. 1 is not included here. 1 is not there because open interval of 1, 3 is, for example, 1, this is 3. After 1, we can take 1.001 like that up to 2.9999. This set is called open interval of 1, 3. Means what? Means what? It is the set of 1 point, suppose 0001 and so on, like that 2.9999, just like that. It is called open interval of 1, 3. Already I said all the meanings. Okay. So 1 is not included here. 1 is not belongs to, therefore 1 is not belongs to open interval of 1, 3. That's why. So this is first step over. Next, second step, I am taking x equals to 1. So put x equal to 1. Tan inverse of 1, it is pi by 4. Next, cot inverse of 1, it is also pi by 4. So pi by 4 minus pi by 4, it is 0. LHS value equal to 0. You come to RHS part. X equal to 1. X equal to 2 minus 1. 1. Cos inverse of 1 is equal to 0. So therefore, 1 is satisfied by the given equation. Where is 1? 1 is not here, but 1 is here. Therefore, bluntly we can represent the right option is third option. 1 minute. So this is finding the set of values of x by the verification. For some problem we can go through the verifications, but for some problems we are following strictly the procedures. So on practicing you can represent in so problem what we should follow, the verification method or direct procedure. You will have to find on practice. That's why practice well. The number of solutions of the equation 3 cos inverse x minus pi by 2 equal to 0. So it can be written as 3 into cos inverse x, that is equal to pi x plus pi by 2. So we see that on LHS part it is a trigonometric function. In RHS part it is a geometrical function or algebraic function. It is in the form of ax plus b, means it is a algebraic function, it is a trigonometric function. Whenever in LHS and RHS two different functions are there and the question is find number of solutions, then 99% it is better to go through the graph. Therefore, we are following the graph. First, we draw the graph y is equal to 3 into cos inverse x graph. First, to draw the graph of y equal to 3 cos inverse x. Okay, here this is x axis, it will be y axis. Actually, domain means x belongs to closed interval of -1 comma 1, and range means cos inverse range, cos inverse x belongs to closed interval of 0 comma pi. So therefore 3 into cos inverse x is belongs to closed interval of 0 into 3 0, 3 pi. So y belongs to means if y equal to 3 cos inverse x, this is x belongs to closed interval of -1 comma 1, and y belongs to closed interval of 0 comma 3 pi. This is x range and there is y range. So therefore take some random values. This is y. On y we have to take 0 comma 3 pi. On x -1 plus 1. So this is a plus 1. At the same distance it will be -1. So function is y equal to 3 cos inverse x. First x equal to 0. Put x equal to 0. Then y equal to 3 into cos inverse of 0. Cos 90 0. Cos 90 0. So 90 degrees equal to cos inverse of 0. So it is 90. So therefore 3 pi by 2. Total, for example, it is 3 pi. Next it will be 2 pi. Next it will be pi. Take like that on y-axis. 3 pi by 2. 3 pi by 2. So this is 1 pi by 2. Next 2 pi by 2 means pi. 3 pi by 2 means 270 degrees. Maybe here. So plot the points like that whenever x equal to 0. Okay. Next x equal to 1. Put x equal to 1. Put x equal to 1. Then y equal to cos inverse 3 into cos inverse of 1. Cos inverse of 1 0. Because cos 0 equal to 1 and 0 degrees equal to cos inverse of 1, just like that. So that is equal to 0. Means when x equal to 1, y value 0, like that. At the same time, remember cos x graph will be like that. This is minus pi by 2. This is plus pi by 2. The graph is y is equal to cos x. Already in introduction class, what I said, cos inverse x is the reflection of cos x, with respect to the line y is equal to x. Once again, I wish to recall, cos inverse x graph is reflection graph, of which cos x graph. What is the mirror? Where is the mirror? Y equal to x. So this part will be like that. So the curve will become like that, just like that. Okay. Next put x equal to -1. Then y equal to 3 into cos inverse of -1. So that is equal to 3 into cos inverse of -1 means pi minus cos inverse of 1. Cos inverse of 0. So it is 3 pi. When x equal to -1, then it will be 3 pi. This is 3 pi, like that. So it will be, next we can take another value, -1 by 2. Then put x equal to -1 by 2. Then y equal to 3 into cos inverse of -1 by 2. So that is equal to 3 into, bracket begin, pi minus cos inverse of 1 by 2. So that is equal to 3 into pi minus cos inverse of 1 by 2, 60 degrees. 60 means it is pi by 3. So 3 into 2 pi by 3. 2 pi by 3. So 3 cancel, it remains only 2 pi. So 2 pi, where is 2 pi? Here is for x equal to -1 by 2. So it will be, the image will be like that. The image will be like that. So it is the graph of y equal to, it is the graph of y equal to 3 cos inverse x. Okay. You can take some random values, meanwhile x equal to 1 by 2, just like that. We can represent the point y value, y equal to 3 into cos inverse of 1 by 2, just like that. Okay. Next, another graph. Draw another graph. Y equal to pi x plus pi by 2. For example, put y equal to 0. Y equal to 0. Then pi x plus pi by 2, that is equal to 0. Then x plus 1 by 2, that is equal to 0. Pi by cancel. Then x equal to minus 1 by 2. Means what? X equal to minus 1 by 2. It is x equal to minus 1 by 2. X equal to minus 1 by 2. Y equal to 0. Okay. This is y equal to 0. X equal to minus 1 by 2. Minus 1 by 2. Pi x actually it is pi x equal to minus pi by 2. So, okay, pi cancel. X equal to minus 1 by 2. Next, put y is equal to, put x equal to 0. Put x equal to 0. Put x equal to 0. Then simply y equal to pi by 2. Once again, when y equal to 0, then x equal to minus 1 by 2. When x equal to 0, y value plus pi by 2. Plus pi by 2 means what? It is pi. Pi by 2 means correct half. So therefore, we can draw the straight line. We can draw the straight line just like that. So LHS part, it may not be at pi by 2. It is out of question. Let it be. So this is the line y equal to pi x plus pi by 2 straight line. It will be y equal to 3 into cos inverse x. It is x-axis. This one is y-axis. Anyhow, for LHS and for RHS, take some random values and plot the points and obtain the graph. Now the question is the number of solutions. Number of solutions means number of points of intersection of two graphs. Actually here only one is there. That's why how many common solutions are there? Only one. That's why second option is right. So therefore the number of solutions for LHS is equal to RHS is the number of points of intersection here, that is equal to only one point of intersection is there. That's why total number of solutions only one. So therefore, whenever LHS and RHS are different, contains different functions. One is inverse trigonometric function, another is a geometrical function or algebraic function. Just like that, in such a case, it is better to follow the graph to find the total number of solutions or total number of common points of intersections. Over.